All right, this question says find the distance between two given points. Now, there are two methods to find the distance from two given points. The first one is actually to go ahead and graph, and we could go ahead and use the Pythagorean theorem to go ahead and solve for it, the distance between two given points. However, this is actually best if you have the coordinate grid. In this case, we do not have the coordinate grid. So the second one is we're going to use what's called the distance formula. The distance formula. Now, the distance formula, it's not hard to derive. We could still use the distance formula coming back from the Pythagorean theorem. These two go hand in hand. So let's think, for instance, what is the Pythagorean theorem? Who remembers what the Pythagorean theorem was? Say it. A squared plus b squared is equal to c squared. So we're going to derive the distance formula from the Pythagorean theorem. So look what, this is, we're going to go ahead and work it out. Ready? We're going to use it from here. This will be a squared plus b squared is equal to c squared. All right? From here, what we're going to go ahead and do is we're going to take the square root of both sides. This will cancel out. So now we have a squared plus b squared is equal to c. All right? But now, if we think about this, because we have two given points, we have point 1 and point 2, which this will be denoted as x1, and this will be x2, and this will be y1, and this will be y2. So the next step in deriving the formula, all right, will be this. We'll take the square root, and this right here, instead of saying a, we're going to go ahead and substitute just x1 minus x2 squared plus y1 minus y2 squared is equal to c. That's the distance formula. Notice that for some students it's very long, complex, but you could still get it from the Pythagorean theorem. Now we're going to go ahead and apply it. These 2 points over here we're going to go ahead and use. So the first point is what? 5.5. So we're going to go ahead and, first thing I want you guys to do is, when you guys have your point 5.5 comma 0, and your next point is 2.75 comma 4.5. The very first thing we want to go ahead and do is we want to label it. Which one is going to be x1 and x2? I could put this one as x1. I could put this one as x1. If I put this one as x1, this one has to be y1. And if I put this as x1, this one has to be y1. So I'm going to go ahead and put it on. I'll put it as x1, and this will be y1. Then this one has to be what? Very good. x2, and this one has to be y2. That's the very first thing you should do. So the next thing I'm going to go ahead and do is I'm going to plug it in. This will be parentheses. x1 is what? 5.5 minus what? Nope. 2.75. And we're going to square that. And then we're going to add. And what's y1? 0 minus what? Is equal to c. Which c in this case, guys, means distance. Alright? I want you guys to understand that. That's what the distance formula is about. So once we have this, we could go ahead and work it out, guys. What's 5.5 minus 2.75? What is 5.5 minus 2.75? What is it? 5.5 minus 2 is 2.75. Plus, what's 0 minus 4.5? Negative 4.5, very good. Is equal to d for distance. Now, we have 2.75 to the second power. What does that give me? Seven point 25 plus 4.5 to the second power is what? Will it be positive or negative? It will be positive. Because this is negative 4.5 times a negative 4.5, correct? A negative times a negative will give you a positive, so we have that. Now we have to combine these two here. Alright? Gives me what? Correct? So now we have to take the square root of that, which gives me the distance is approximately, if we round to the hundredths place, it will be 5.27. That will be your final answer. Any questions? Notice, guys, that you did step by step by step by step. Practice doing this again and again. Yes, sir?
When you put on top of your you put C and then you put D, they're still the same, right?
Yes, sir. Just when you look at the formula is going to say this here, the whole thing, and it's going to equal to D instead. But I put C on it so you guys can know how I derive the distance formula from the Pythagorean theorem. You understand? On the test, I believe, if I'm right, I got to double check my notes. I believe the distance formula is given to you guys. All right, but it's good practice to learn it. It's good practice to memorize the distance formula because you will see it again in Algebra 1, Algebra 2, Geometry. You'll see it a lot. So it's a good practice to learn it. Any questions with this one over here? All right, let's take a look at the next question. I'll show you the answers at the end, guys. Again, this is a distance formula here. So it says round to the nearest tenth. So we're going to go ahead and do the same thing. This is question number 2. Distance. And we're given the points to be negative 5, comma 2. And we have 5, comma negative 2. All right. So again, we need the distance formula. Well, the distance formula, if you don't remember the distance formula, you could use what? So I'll write the Pythagorean theorem again. This will be a squared plus b squared is equal to c squared. Well, I know I have to take the square root of both sides, so I'll take the square root here and here. This will cancel out. So the Pythagorean theorem, or the distance formula, is very similar. A squared plus b squared is equal to c. Well, a is to be x1 minus x2 plus y1 minus y2. So I'll go ahead and write it down. All right. This will be x1 minus x2 to the second power. Don't forget the second power, very important. Plus y1 minus y2 to the second power, and all of that is squared, is equal to b for the distance, okay? Now, again, very important. This right here, these 2 points, you should label it as what? X1, then this one should be?
Y1.
Does it matter which one you label x1, y1?
No.
Doesn't. So this will be what?
X2, Y2.
So let's go ahead and plug it in now. What's x1? Good. Minus, what's x2?
5.
Squared. Plus, what's y1?
2.
Minus what? So guys, what's negative 5 minus 5? Try it again. Negative 10. What's 2 minus negative 2? 4. Negative is a what, guys? So this is 4. So here we go. What's negative 10 times negative 10, or negative 10 to the second power? 100. What is 4 to the second power?
16.
We've got to combine these two. And then we take the square root of that. 10.77, right? So it's approximately 10.77. Is it what, round to the nearest tenths or hundreds? Tenths. So it'll be what? 10.8 is approximately B. Any questions with this one over here? Correct. Question number 3. All right. Question number 3 says we have this figure here. This is x. This is x plus 10. And this is 154 degrees. The question says find x. All right. The question says find x. Well, there's a couple things that we could apply here. What do you guys think we should do first?
Find the opposite interior angle of that 154.
You heard what he said? He said, if we know this is a straight line here, we know this angle here. How do we know that angle here? What property are we using? You said it. Supplementary. Supplementary angles. Let's say we're going to call this y, all right? So we know y plus 154 degrees should give you what? 180 degrees. So how do we solve for y then?
Subtract 154.
Subtract 154 to both sides, right? Y is equal to what? 26 degrees. So this is 26 degrees. So what else can we apply here now? What is it called?
The triangular sum theorem.
Very good. I'll accept that. It's actually the triangle sum theorem? Everyone say triangle sum theorem. That triangle sum theorem says that this angle plus this angle plus this angle should give you what? So what is this angle here, guys? X plus, what is that angle there? X plus 10. And what is this angle? Plus 26. Should give me what? 180 degrees. Well, once we get to this part here, there's some things that we could combine. What can we combine? 26 and 10 is one of them. What does that give me? What else can we combine? X and X. What is X plus X? 2X. Very good. Now we have to solve for the variable. What's the variable? X. So remember the rules I told you guys. We always want to solve the variable. What should we look at first? The number that's what? Furthest away from the? What's the number furthest away from the variable? 36. We got to get rid of that first. So how do we get rid of the 36? Alright, so we subtract. What you do to one side, you must do to the other side. This cancels out. What do you do with the 2x? You bring it down. Very good. 2x is equal to what? 144. So what should be the next step? By? What do you do to one side? X is equal to? We're done, guys. That's my answer, 72. Alright, let's look at number 4. Number 4, the picture, the image is not that great. I'll try my best because it could be kind of deceiving. Alright, so for number 4, I'm going to go ahead and draw it out for you guys. Alright, we have this. And we have this here. All right. Now, question, if you look at number 4, let me go like this and let me go like that. And we know that this is x plus 25 degrees. And I want to say it's this one here. 3x plus 27 degrees. All right. So, is it that one?
I think it might be the other one, which is 3x smaller.
Well, let's try this one out, and then we'll determine if it's this or this, okay? First things first, guys. What do we have here? What is this called? How do you know it's parallel lines? You see these two little marks right here? If it has those two little marks, that means these two lines are parallel. So this is a special name. It's actually called parallel lines cut by a transversal. You will see that in geometry. Parallel lines cut by a transversal. There's a couple things that I told you guys, that I taught you before, that I told you guys. When you look at different parts of parallel lines cut by a transversal, there are things that are going to be congruent. What does congruent mean? They're the same. They're equal. So these two angles, for instance, all right, it has a specific name. All right, when you have one over here and the other one's over here, this is called vertical angles. Those are called vertical angles. Vertical angles are congruent. Another example will be, let's say if I give you, this is A and B. Angle A is congruent to angle B. Why? Because they are what? Vertical angles. Alright? So if they're vertical angles, we could say that these two are going to be exactly the same. 3x plus 27 should be equal to x plus 25. So we need to solve for x. Well, when we solve for x, we got to bring one of the x's over to isolate the x. I'll go ahead and bring this x over to this side. How can I bring this x over to this side? Subtract x. What you do to one side, this will cancel out. What's 3x minus x? I should bring this 27 over to this side, which should give me what? What is it? It's actually going to be minus 27. So negative what? Negative 2 and divided by 2. X is equal to?
Wait, what happened to that 3 on top?
Oh yeah, what's 3 minus 1? 2.
Oh.
So x should give you negative 1 for this one here. Any questions over here? We good?